Hey guys, how's it going? Today I'm going to do a video on wiring my glycol chiller. Someone asked me to post this and do instructions on how to wire out the old control and put in a mechanical control and use an ITC 1000, which you can get from Amazon, to basically cycle the unit on and off. The reason you would want to do this is, one of the reasons I did it is the controls, they have like different settings that you can do for cooling, and they don't go down as cold as you need to do for what you want for glycol chilling. And the other thing is the sensor that's connected to them isn't long enough to be able to put into the glycol. So you need a different sensor that won't hook onto the board. So you're better off to get rid of the board. And basically also I removed the power board itself as well, so that all you've basically got is wiring and the ITC 1000, and also I put in a separate contactor for my compressor, which I'll show you why I do it, because I don't trust using the ITC 1000 points in there. But it's pretty straightforward. But there's a disclaimer I have to tell you right now. I am a refrigeration mechanic, and so I do know what I'm doing when it comes to wiring of air conditioners and other things that are related to refrigeration. I'm not an electrician. This is not a how-to for wiring. This is just what I did. If you are going to do this, as I said again, I'm not saying this is what you should do. This is what I did. You should always contact someone that knows wiring, like an electrician or refrigeration mechanic. Ask them to look over your wiring. Make sure that you're using good products, good wiring, connections are all good, because besides becoming electrocuted, which you don't want a fire, because you might be running this inside your house, which I do, but I was careful in making sure that I felt safe, that this unit was not going to be unsafe. So with no further ado, that's my disclaimer. Let's check out the wiring. Cheers. Okay guys, so basically someone asked me on my channel if I could do this video showing you how to remove the control board from the air conditioner that I built a glycol chiller with. So as you can see, I've got a picture of it. I threw it out, so luckily I did find a picture of it, and I'm going to explain what you're looking at, what I remove, and why I remove it. The end result is basically to have a glycol chiller that doesn't cost you $1,500 to $2,000. I think it cost me about $200 total to do this project, but it was a fun project. And with no further ado, let me get into the wiring and what I've done. So if you take a look, it's hard to kind of see, if there's two little red arrows there I've drawn, and those two blue connectors there, that's the relay that opens and closes to turn on your compressor. So those two are going to come off, and they are going to be put onto a contactor that I purchased. And some people will actually do that through the ITC 1000, but I don't believe in doing that because I don't think the points are strong enough. So I'm actually going to separate. That relay is going to become a separate contactor that I'm going to use, and those wires will come off for that reason. So if you look at the ITC 1000 wire diagram, you can see the power supply in the lower left side comes into 1 and 2, and that's what powers the control all the time. 3 and 4 is the temperature control, which you do get a temperature control when you buy one of these off of Amazon. I did anyway. I also went with the 110 volt unit because I plug it in and I need it to run the air conditioner. That's what you have, 110 volts. If you take a look, it also has a heating and a cooling circuit. The heating circuit I am not using. Other people do sometimes use it, but I did not. The cooling circuit's what I want to use. Now if you take a look on the upper right side where it shows the circuit, it says it's good for 10 amps is what they say, but these are tiny relays, and I've seen people online use these and actually have fires inside of the ITC 1000. So what I did is I used the points in that contact to open and close the coil power to a separate relay that I bought online.
and it was a 30 amp rated contactor. And a contactor is not a relay. It's meant for running things like motors or compressors, which have what's called back EMF, which is electromagnetic force, which can cause heat to be generated. It's not like opening and closing a coil or a circuit for a heater. This is different. It's a motor. So that's why I didn't want to use the ITC 1000 to open and close the circuit directly from my compressor. That's the difference I've found on what I've seen online for wiring. So let's go into more detail on that. So sorry for this picture is horrible. If you take a look, it's really hard to see, but this is the box that I built out of the original air conditioner. You can see it's metal inside, surrounded by wood, but the part that's kind of hanging in the center there, a little lower to the left, that black part is the contactor, and that's what I used in conjunction with using the ITC. It was so that it would take the load of my compressor. I advise, if you're going to do this, to make sure that everything is mounted firmly and safe. And I also, like I said, use that metal interior box, so if I had any kind of an electrical issue or something shorted out, it was going to be grounded, because I also put my ground on there as well. So don't just, some people build things out of wood. I would advise not to build it just out of wood. Try to make sure that all your electrical components are basically tightened and grounded in place with a metal box that is also grounded to your wiring that goes into your outlet. So if you take a look at this diagram, I took this right off of the actual air conditioner itself, and you can see I've circled in red where the relay is that I am just connecting off the control board. I've underlined where the compressor is, where it's the CM stands for compressor motor, and one side of that comes off of the capacitor, which is to the lower right side of that, which is that round thing that has 3 other connectors on it for wires. And the other little wire can come off the top left of the compressor motor is what goes through that circuit, which we are removing. Those points that I circled on that board are the ones that are going to go on the contactor that I am going to add to my circuit, which opens and closes with the relay of the contactor coil being energized through my ITC 1000. If you take a look, also I've circled where the fan speed is. There's 3 wires that come off. Basically, one of them that where I pointed to, it says M, that's the fan motor. One of them is the common, which we'll just put that onto our common, which is the neutral on our plug. The other 3 are for low, medium, and high speed. We're going to take all of those off, and we're going to actually cap off or put a marret on the low speed and the medium speed, and we are just going to directly connect the high speed, so that when my contactor closes for my compressor, I will also power up the high speed of the fan. The compressor always runs with the condenser fan motor on all circuits to do with air conditioning, unless they're having a headmaster for other reasons. But in this application, every time the compressor runs, the fan is going to run as well. So we're basically taking this out of the circuit. And people would ask, well, why is there a low, medium, and high speed? Well, it depends how hot it is outside when you're dealing with an air conditioner. We're probably just dealing with an ambient temperature in a home of like 70 to 80 degrees. So let's just go with the fastest speed, and we don't have to worry about it. And the controller, we're removing it, so we're not going to be able to select different speeds, and we don't care for this application. So if you take a look at this, you can see where I've also circled the blue wire that comes off of the board and goes to the capacitor. This is a neutral wire, and at first when I saw the board, I was like, okay, it just shows this blue wire coming off, and I traced it to the capacitor, and I wasn't sure what it was at first, but it's just basically the neutral side of that capacitor. So it's going to be tied in to our neutral. In wiring, anytime that you're breaking a circuit, you should be breaking the hot line. You always have your neutrals tied into each side, and then you would then cut or open and close with different components and circuitry your live wires. So I'm going to show you right now. If you take a look at the actual board, there it is. It shows you can see I circled it, the blue wire, and it shows an N right below it. That stands for neutral. So that wire is going to get basically marretted onto your neutral side of your circuit. So now if you take a look at again at the ITC, and if you think about it, there's your power coming in. Like I said, that's not going to change. The power supply that comes in to your ITC is what runs the board constantly. It's never going to be a broken power. As soon as you, unless you want to put a power switch in, you could, and you could break the circuit. But as soon as you would plug in your unit, you would basically have power to it. Now the cool thing about the ITC, it does have an on-off power switch. If you hold the power button, it turns on or off, even though there's power to it all the time. So that's how I have it wired. Now the temperature control comes with it, which I said is number 3 and 4. You wire that directly into 3 and 4. The board itself shows you 1, 2, 3, 4, 5, 6, 7, and 8, so you can't confuse it. You wire that in, and you then put it into the glycol solution, which is what I generally did. Now, thermistor probes, there's no, I believe in these, there's no right or wrong way. There's certain things like thermocouples there is. So just test it out. It's pretty simple. You put the 2 wires into 3 and 4, and you could take ice cold water and just put the probe into some water and see if the controller reads the proper temperature, which would be 32 Fahrenheit or 0 Celsius with ice in your water. When you take a look at the cooling, as we talked about before, and it shows that little kind of that circular oval shape there, and it says cooling, that's just supposed to be that's the motor, or that would be where you would give power to the contactors, the coil of the contactor, which would close and run the circuit of your compressor. So that's basically what I have done, is I've used the one side of it, number 8, I would come out and go to one side of the 110 volt coil of my contactor, and the other side that comes from line 1 over where it says power supply 110 VAC, and you can see where it presses in, or it goes into number 1. That is the live line. I would then have that on the other side of my coil. So where it says cooling, that's actually my coil wires for my contactor. And then I'm just going to quickly go back to the other wiring diagram of the unit, that of the air conditioning unit, and I'll explain what I am doing again with my contactor, what power I'm opening and closing. So back to the circuit diagram of the actual air conditioner itself, and you can see where I've circled on the control board, which we are removing. Those are the points that open and close to send power directly to your compressor. So instead of having that board doing it, I'm going to have myself a contactor, which I bought online for, it was a 30 amp rated contactor. And as I said, and I don't want to go into huge detail about how a contactor works, but it has an electrical coil. When energized, the contacts close. When de-energized, the contacts open. If you want to read more about that on the internet or watch any YouTube channels on it, they'll explain how an electromagnetic contactor works, how it's energized and de-energized. But basically, I am using a 30 amp rated contactor in place of where that control board is, where other people would use the Inkbird. I don't trust the Inkbird whatsoever. It says it's rated for 10 amps, but I'm sorry, maybe rated for 10 amps on a resistance coil, which is something like a heater, but for a compressor, I do not want to use it. I do not trust it. I have seen videos of people showing how their Inkbirds have caught fire. The Inkbird does have, if you take a look at it, fins on the side of it. Actually, I'll show you a picture of it right now. So there they are. The cooling fins are in the right hand side if you take a look at that picture. The little orange tabs, that's what holds the ITC in place. On the left hand side of this picture, that's the front. You can't see it, but this is a side view. But those little slots on the right hand side, there's about 1, 2, 3, 4, 5, 6, there's like 12 of them. There's 12 on each side. Those are important that they're not blocked. Those are cooling fins. They're cooling areas for the controller to keep basically allows it to breathe. So when I put mine in place none of those are obstructed. You can mount this any way you want, but make sure that those are not obstructed. I've seen people put these in a box, in like a little plastic box, thinking it's, oh good, it's not going to get wet, but it can breathe and it gets hot and it can catch fire. So just remember that those are cooling fins and they're there for a reason. So just to quickly go over this again, you can see where I've circled where the compressor points are on the board that we are removing, which I'm going to use a contactor, which will be energized with the coil from using the ITC 1000. Also, as you can see on the next diagram here, I am removing 3 of the colored wires for the condenser fan motor because we don't need 3 speeds. We're just going to pick the high speed. If you're not sure which one's which, you can just basically wire each one in until you find out which one. Now, again, these 3 wires, they are not neutrals, these are live. The neutral one is at the bottom, you can see, that comes out of the fan motor. That one gets connected to the neutral. As I said, we're always connecting all neutrals. The other 3 wires, you can figure out which one is your high fan speed, or if you don't want to use that, use a lower one if it's too loud for you. But that's what we're doing, is we're just going to connect that to the load side of our compressor contactor, the one that we're adding. Okay, so when that contactor closes, it's going to energize the compressor and the condenser at the same time. And now looking again, as you see, you've got the blue wire, which I showed you. They wondered what it was for coming out of the board. That blue wire is your common that goes to your capacitor. That also will just get wired directly into all of your neutrals as well. If you guys have any questions on this, you can please post them on the comments down below, and I'll try to answer everything I can. I'm sorry I didn't go drawing a diagram for you, but it's a pretty straightforward wiring. And again, as I said in the beginning of my disclaimer, make sure you're safe. If you're not too sure about wiring, don't just try it. Have someone, I'm sure some of you guys must have a buddy that's an electrician or a refrigeration mechanic that you can ask to double check your wiring before you try running your system. I hope this helps, guys, and have fun, man, because I'm so happy that I did this and I saved myself over $1,000 easy, and it was a fun build. Hope you guys enjoyed this video. Thanks, guys. Cheers.